All right. The last thing I want to point out in this presentation is when we say a causal prediction happen, what does it mean? What does it mean um, for the perspective of causal diagrams? In this part, we are always talking about the causal diagrams. So you see here, when a prediction occurs, then mechanism of natural force will disappear, right? So our question is, what does it mean if we remove some mechanism in the diagram? And I would like to say the metaphor is we can think of it like we will slim down the causal diagram. The diagram is consists of many edges that are represented as causal relations among factors, right? And as we have seen before, some of the relations uh, does not exist when it comes to some specific scenario, right? So that means we can reasonably remove some edges. So in the following, I will give you a quick look. Notice that I didn't show you how I get this connection here, but just let me show you a big picture. Here I add a new factor, the weather background, and I say the weather background have something to do with the governments and the emission migration. Maybe the factor the weather condition will affect the government's activities, and it will affect the formation of some natural process. Okay, so this is a general scenario, and we got a general causal diagram. So now, what if I set the weather background as blizzard? So if you think of it, when when we are in a cold environments, the nature force represented as mega fire are less likely to be happen, right? That means the causal link um, stemmed from the nature force would be pretty weak. So let's just remove these edges. Okay, so we got another causal diagrams, diagrams that are what we call we slim down the causal diagrams of removing those edges for a specific scenario. And this will come down to a new terminology, and this is equally important. We call this new causal diagram as the causal beam. So we don't talk about many details about the causal beam, but I think maybe a rough conclusion we need to remember here is that a causal beam is a specific causal diagram designed for a specific scenario, and the defining feature of causal beam is to help us determine which one is the actual course. You see here, no matter what happened, no matter what condition we set, there is nothing can influence the human activities. So the human's influence are always exist. Uh, we are the only one person who can control what we do in the world, right? So that remind edges in a causal being implies that human influence are the actual cause of the climate change. Okay, uh, so far I have answered the question I put in the second part. Now let's go back to it. Uh, how do we face the problem of insufficiency of analysis of courses? And and um, and the language of causation we're seeking for is by borrowing the wisdom of sufficiency and necessary analysis, and that is nothing wrong about it. So for the question of insufficiency, the only one thing we need to do is to change our basic from the causal diagrams to the causal beam, and we apply this principle, the principle of sufficiency and necessary causal analysis, into the causal beam, and this will help us to determine the real course. Okay, so if you accept this idea that I've discussed in this presentation, then you will accept the idea of what we call the sustainer space causation. And this is the primary idea that you can find in the last chapter in the book Causality by Julie Poor. So I here in this presentation just give you some brief intuition. If you need to know more details, you can head into the book. Okay, so this is the full content for our first